Hello everyone, welcome to this video. In this video, we shall be looking at question 5 from exercise 9.3. So here in this question, they are saying which term of the following sequence, this sequence is given to us. They are asking which term is 128. So let's have a look here. So here the first term is given to us as 2. We can calculate the common ratio by dividing the second term with the first term. So this is what we are doing, 2 into square root 2 divided by 2. So you see this 2 and this 2 cancels with each other, and square root 2 is the common ratio, right? A is known to us, R is known to us, an is also known to us, 128. We need to find what is that value, what is the position of this an, right? So that will be determined by the number small n, correct? So we can use the formula for the nth term here, which is an is equal to a r raised to power n minus 1. We can substitute the value of an as 128. We can substitute the value of a as 2. We can substitute the value of r as square root 2, and we can now solve for the value of n, right? So you can shift this 2 to the left hand side. So you will divide by 2 on the left hand side, so that you would have 64, right? On the right hand side you would have square root 2 raised to power n minus 1, right? Square root 2 raised to power n minus 1. So therefore now you see, when you take the now we wanted to convert this into powers of 2 and this also into powers of 2. It is already in powers of square root 2. We will convert it into square root power of 2. You know, you can write the square root of 2 as 2 raised to power 1 by 2. This is the usual notation, right? So therefore square root 2 raised to power n minus 1 would be 2 raised to power 1 by 2 raised to power n minus 1, right? Now there are two powers, you know, 2 raised to power a raised to power b, it is equal to 2 raised to power ab. So we can use this thing over here. 2 raised to power a into b would be equal to the multiplication of both. So it would be 2 raised to power n minus 1 into 1 by 2, which is divided by 2. So that is why I have written this square root of n minus 1 as 2 raised to power n minus 1 by 2. This is one thing. Another thing, we can take the prime factorization of the number 64. This number is 64. We can divide it, we can take its prime factorization. We can divide it by 2, right? So you see, you would have how many 2's? 1, 2, 3, 4, 5, 6. So you can write 64 as 2 raised to power 6, right? So you have 2 raised to power 6 here, you have 2 raised to power n minus 1 divided by 2. So when the bases here are the same, so you can compare the powers here, so that it would be 6 is equal to n minus 1 divided by 2. When you solve this, you would have the value of n as 13. Right, so that means this nth term 128 is the 13th term of the given sequence, correct? Now next move on to the second part. The second and third part are similar, the values are given to be different, so you can practice them by your own. For the sake of completeness, I am just explaining the solution to you. I insist you to do the questions by yourself and then check and match your answers and see if there is doubt, if you stuck at some particular point. Okay, so in this part B, we are given the sequence square root 3, 3, 3 square root 3 and so on. So you see here, the first term is square root 3, right? The second term here, the value of common ratio is obtained when you divide the second term with the first term. So second term is 3, the first term is square root 3. You can write 3 as square root 3 into square root 3, there is no issue. So this one square root 3 cancels with 1 square root 3 in the numerator. So we are left with square root 3. So this is the common ratio, correct? The value of a is also square root 3. The value of r is also square root 3. This term is given to us, which is an. We are assuming this to be an. We need to find the position of this term. So that means we need to find what is the value of n. So in order to determine n, we will again use the formula for the nth term. So now an is given to us, it is 729, right? The value of a is given to us, which is square root 3. The value of r is given to us, which is also square root 3. So substituting the values here. Now you see, here we have power 1 of square root 3. Here we have power n minus 1. You see, if we have the same power, say x raised to power a into x raised to power b, because you have the same base, the powers would add, So you would have x raised to power a plus b. Similarly here also you would have square root 3 raised to power 1 plus n minus 1. So minus 1 and 1 cancels. So we have square root 3 raised to power n equal to 729. Now we wanted to convert it into powers of 3. So what we can do, we can take the prime factorization of 729. So you see in the prime factorization we have how many 3? 1, 2, 3, 4, 5, 6. 6, 3. So you can write 729 as 3 raised to power 6. And similarly you can write square root 3 raised to power n as again 3 raised to power 1 by 2 raised to power n. So that would be 3 raised to power n by 2. Now because the bases are the same, you can compare the powers. So it would be 6 is equal to n by 2. So your value of n comes out to be 12. So that means the 7 to 9 here is the 12th term in this sequence, right? Now next let's move on to our third part. For the third part, we are given the first term as 1 by 3. We can calculate the common ratio by dividing the second term with the first term. So we have 1 by 9 divided by 1 by 3, which comes out to be 1 by 3. And this is our nth term. We need to find the value of n. Again, using the nth term formula, we can substitute the value of an, the value of a, and the value of r, and we need to determine the value of n from here, right? So for doing that, you see we have power 1 here, we have power n minus 1, so combining the powers, it is power n, right? Now we can factorize this thing. When you factorize this thing, you see how many 3's do we have? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this term could be written as 1 upon 3 raised to power 9, and we already have 1 upon 3 raised to power n. So first of all, we can take the reciprocal of the terms, so that we would have 3 raised to power 9 is equal to 3 raised to power n. Now the bases are same, so therefore the power should also be the same. So therefore n is equal to 9. Hence whatever is this term, this is the 9th term in the given sequence, correct? So this is about question 5. Now we can move on to the next question, which is question 6. In the question 6, they are saying for what values of x these three numbers they are in GP. Right, so the numbers are given to be minus 2 by 7, x, and minus 7 by 2. So now you need to know what is the basic property of a geometric progression. The basic property of geometric progression is that when you divide any two successive terms with the preceding term, so when you divide any term with its preceding term, the ratio comes out to be the same. So that means when x is divided by minus 2 upon 7, that would be your common ratio, right? Suppose r is the common ratio. So when you divide x by minus 2 by 7, that is your common ratio. And when you divide this third term minus 7 by 2 with the second term, then also it is equal to the common ratio. So let's mark this as equation 1 and equation 2. Now when you compare equation 1 with equation 2, you see this term is also equal to r and this term is also equal to r. So that means both the terms should be equal. From equation 1 and 2, we may say that this term is equivalent to this term. So this is what we are doing. This term is equivalent to this term. So we can solve for x. We can cross multiply on both sides, so that we would have x square is equal to minus 7 by 2 multiplied with minus 2 by 7. So you see this and this cancels, this and this cancels with each other. Minus 1 is multiplied to minus 1 gives you plus 1. So x square is equal to plus 1. What would be the roots of this equation? That are very simple. They are plus 1 and minus 1. And this is what give you your GP. So your GP would be minus 2 upon 7, 1 and minus 7 by 2. That is quite simple, right? You can check the common ratio is the same if you divide the second term by the first term, or you divide the third term by the second term. And moreover, we also have this GP minus 2 upon 7, minus 1 and minus 7 by 2. This also forms a GP. Here the common ratio comes out to be minus 1 divided by minus 2 upon 7. How much is it? Minus and minus cancels. It is 7 by 2. And in this case, the common ratio comes out to be 1 divided by minus 2 by 7. How much is it? It is minus 7 by 2. Right? So this is your two GPs which are obtained when you have these three numbers, correct? So I hope you understood these questions well. That is it for this video. Thank you for watching.